Hi everyone, and welcome to today's webinar, The Value of Model-Based Systems Engineering. My name is Donna, and I will be your host during today's webinar, presented by Mark Simons. We're excited to present 3 case studies of model-based systems engineering conducted for the U.S. Marine Corps. Our lead presenter today is Mark Simons, a lead systems engineer at the MITRE Corporation, and is currently advising the Marine Corps Program Manager for Marine Intelligence with regard to model-based systems engineering. Previously to his work with the Marine Corps, Mark applied MBSE techniques to the development of net-enabled communication for the Federal Aviation Administration. Before joining MITRE, he worked at NASA, holding a variety of technical positions in the development and operations of ground data processing systems. Mark has also taught in the Systems Engineering program at the Johns Hopkins Engineering School for Professionals. He holds a BA in Mathematics from the University of Utah, an MS in Operations Research from the George Washington University, and an MS in Systems Engineering from Johns Hopkins University. Before Mark gets started, I just have a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions as soon as you think of them through the question tab on the webinar control panel. Mark will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. This webinar is being recorded today. If you experience connection problems during the live presentation, recording will be available within 1 business day of the live version. The recording will be published to Vitech's webinar archive located on our website. I will send the link out in the chat window now. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Now I'm going to turn the presentation over to Mark. Welcome.
Hi, Donna. Thank you very much. Just wanted to let people know that this presentation was originally a briefing that I gave at a recent conference, system engineering conference hosted by the National Defense Association, Industry Association back this past, I think it was last fall, and Zane Scott of Vitech was there in attendance and felt that this would be a really good presentation for a Vitech webinar. He appreciated the message that I was presenting there concerning the value of MBSE, and so that's going to be the real thrust of this presentation today, is the value. As Donna mentioned, I've applied MBSE to the Program Manager for Marine Intelligence, which is an organization within the Marine Corps, and I'll be explaining how we were able to, describe that value and show that value to our sponsor. And let's see if I can advance my slides here. And so as an organization for the presentation today, I'm going to talk at length really about my approach for MBSE that I've taken, and I'll explain and define MBSE, try to deconstruct its meaning, and there's a lot of different meanings for different people, different organizations, and I'll explain that approach and also talk about what it means and what the benefits are really, and then I'll talk about the value. I want to kind of talk about that in general terms first, so we can understand, get on kind of the same understanding, and then I'll talk about the 3 case studies that Donna mentioned that where I was able to foster some value for my sponsor in 3 different areas. Before I talk about the case studies, though, I'll give you a quick overview of the Marine Corps, just to give you a little bit of background on that. All right, so the next slide here is my first entree into MBSE and what it means. Now, one of the themes that came in the conference was, the differing definitions of what MBSE is to different people. Many people in the track were showing modeling and simulation applications for model-based system engineering, and that's a completely valid approach for model-based system engineering. Rather than define like another term, to describe that, or another set of acronyms, another set of letters, what I'm trying to do is just show that how versatile MBSE is, and if we deconstruct MBSE, maybe looking at it in reverse order here, we can see that engineering here is a big part of what MBSE is meant for. We are trying to build systems essentially eventually, and so we can use MBSE here to make our design decisions at a very low level and high granular detail of our modeling efforts. We can also use the MBSE work and knowledge that we have to design different specifications for our requirements, or how to code or fabricate a particular piece of our system. We can use it again for testing as well, and modeling and simulation. Of course, that's going to be a really a big benefit from MBSE and engineering disciplines. But of course, we also have the term system engineering here embedded into the term MBSE, and in system engineering, we're looking at a lot of different aspects of explaining the hardware and software design and how they interact. We're looking at things from a conceptual point of view as well as a detailed design point of view. And throughout that, there's going to be different trade studies, analyses of alternatives. We're going to be defining concepts of operations. We'll be writing requirements, and we'll do some modeling and simulation to help validate and understand that, and MBSE can help with all of those different efforts. And of course, what does it mean now to be model-based? That's the kind of adjective here. And what we're doing model-based system engineering, in my view, is we're building models, and those models help us communicate through language and visualization, and it helps us to communicate and verify and validate what we're doing. So you're getting a lot of understanding here that helps drive that system engineering and helps drive the engineering that comes later. Now, to drive the point home further, when we're looking at just the system engineering part of the equation and the engineering point of view, when we talk about models, we're talking about building models that help describe behavior, the functionality of a system, the activities that are going on in the system. We're describing the structure, how things are designed, how they interact, and we're also modeling requirements, understanding the specifications with the functional and performance specifications for a particular system. And on the engineering side, the more detailed side, we want to look at bandwidth or what our power budget is, or how different technical performance measures might flow down through our system. We want to understand power and weight issues. Maybe if we're building satellites, we want to understand radiation, solar radiation, and how that might affect our power. And so we can build out these models and simulations in order to help us understand all of these aspects of a system development, whether it's on the very granular side of engineering or on the more general conceptual side of system engineering. Now, when we talk about the model-based aspect, we're talking about the modeling and what the model-based can do for us. And in many ways, there's an underlying kind of entity relationship model in an MBSE application, and what this model is providing, it's providing us a way to communicate with words and describe how that system is designed. And so there's a number of classes or entities here called functions or requirements, or maybe some general design element, test requirements, test activity. We can go on, use cases, risks, and we can add to this. And we can see that there are ways where these entities can be related in many ways. In classic system engineering, we know that requirements support a function, and functions support some design element. And then the design element needs to be tested in some way. And then we understand that risk can be there in many different areas. So with a MBSE effort, we're associating our artifacts within our system and system design in a particular way. Now let's see, and so the other aspect here is that we are now able to take all this information that's in this entity relationship model and use that as kind of like a schema, if you will, for like a specific integrated repository of content. So we're putting all our use cases here, our risks, our requirements, our functional design, everything is now in this, notional or database-driven kind of repository of information. And now that becomes a single source of information. And another aspect of this model-based information is that once things are in a repository, we can now begin to visualize that information in different ways. And there are many different frameworks and methodologies for drawing different types of diagrams. And so I'm showing you here some basic ones, showing you hierarchy diagrams, relationship diagrams, design diagrams, activity diagrams from SysML, and this even basic spreadsheets, describing relationships. These are all ways that we can look inside of that repository of MBSE information and visualize that information. It doesn't always have to be created, from the get-go by the designer. These can be all driven by that information that we have in our repository. And then another final aspect about MBSE is it's very important that our models are executable in a way, so that we can visualize and understand the functionality and the behavior of the system we're working. So here I have an example of a generic functional flow in a high-level kind of discrete event simulation that you can use to understand if you have the correct logic and behavior that you've designed, and you've designed it correctly. So these are all kind of how I define MBSE and how I kind of see how it can be used and applied. And the next thing now is how do we sell this to people? How do we describe that value? In the presentation there at the NDA conference, there was a kind of an expressed frustration on the part of all the practitioners about how to really convince our clients, our sponsors, and people within our own organization about what MBSE can really do for us. And traditionally what we do, we talk about it is we talk about this integrated repository and how it can be used as a single set of information where we have all our design elements or functions, etc. in here, and that we establish that single baseline that can provide us end-to-end traceability, it gives us design consistency, integrated development. These are all things as practitioners that we really need, and we know that can help us. And then when we have this repository, now we can kind of like generate the documents. We can generate our architecture. The architecture and documents become a byproduct now of the integrated repository rather than the source of information. And as practitioners, we really understand that. But what I found is that it's hard to sell MBSE based on diagrams like this and descriptions. We need to look at it from the point of view of our customers. And to that end, my single takeaway slide here will be the value of MBSE really is in the facilitation of communication and thinking within projects. So the takeaway is that system engineering is a team sport, and that MBSE provides value to the teaming. It allows effective communication, so it allows us to understand a situation and enables us to help resolve our differences in a depersonalized way. We're taking the people out of the equation. We're using our MBSE information to drive the discussion. And so it takes the personalities out of the situation. We can create trust and respect and creative environments here when we do this. And it's that creative environment that allows us to solve our problems as a group and develop creative ideas. And so MBSE helps us to do this creative thinking, this critical thinking to help us design our systems better. So in a creative thinking mode, we're thinking of our concepts of operations. We're thinking of different ways to help that we can maybe implement certain requirements that drive us to maybe certain trade studies. And it's that creative thinking that gives us, the ability to innovate, right? And MBSE can help us do that. And then when it comes time to really specify our system and start to build it, now we start to use our critical thinking, and we look to see, well, what's achievable? What can we really, what's in the realm of possibilities? And that's where we start to critically analyze our system and kind of break it down so we can specify it and eventually build it. And throughout all this, we can use these artifacts as a way to communicate, whether it's a change we may want to make. It doesn't have to become personal. It can be the artifacts MBSE generates can help drive those conversations. Any questions up to this point?
Mark,
Donna,
yes, we do have one question. It's, did your visualizations eventually map into artifacts using the DODAF 2.0?
Good question. I have one of the case study where that was exactly what we did. We used MBSE to help drive architecture, and we were able to use the MBSE repository and all that information to drive the DODAF artifacts in a sense. Some of that was automated, some of it wasn't quite so automated, but the information was there and everything was consistent, and I think that's one of the key aspects to it. So wait to the third case study that I'll get to here shortly. All right, so moving on, just a quick overview of Marine Corps. I'm going to be talking about our application of MBSE, and you can see here the Marine Corps is part of the Navy, and you have the operating forces and then a supporting establishment where the engineers and the design developers are here, and that is essentially organized and implemented through the systems command at Quantico. When you hear about Quantico, that's where the system command is and where a lot of the engineering happens. And within the systems command, you have a number of what they call program managers, and the program managers are there to develop systems and capabilities in a number of different areas that support the Marine Corps. And one of them is marine intelligence, and that's where I come in, is I'm here to help the Marine Corps and help them understand and develop systems for marine intelligence. And off to the left here, there is also a system engineering, overarching system engineering organization that helps try to bring together all the program managers. And to some extent, we interacted with that SIAT organization to help marry up our approach for MBSE with their requirements for architecture. Now, the program manager for MarineTel, it's intelligence, but in addition to intelligence, you also talk about surveillance and reconnaissance. Basically, PMMI is providing a portfolio of systems that helps the Marine Corps become aware of the battle space. That's the generic capability that's kind of provided by PMMI. And this portfolio of systems is helping them through a lot of different operational activities. Collection, processing, exploitation, analysis, production, utilization, and dissemination. Now, all of these are very well articulated in Marine Corps documentation and policy statements, and we try to make sure that we have capabilities in all of these different areas. And another way to look at the portfolio is through the different types of intelligence that are being dealt with. And one type is the radio, the electromagnetic spectrum, the signals. Another is the imagery that we can take, whether it's geospatial in particular, or whether it's simply photography, or what I'll talk about later as full motion video. Well, in fact, it's the next thing up on the docket. So I'm now starting into the first of three case studies of MBSE, and I mentioned how MBSE is useful for communication, and what I found is that it's also very hard to get started with MBSE from a greenfield approach, just like it is with system engineering. So when I come into an organization that's maybe suffering in some way and needs some help, we're always looking at understanding what the initial conditions are. And I talk about that in terms of like where is the organization at in their design life cycle? What are the issues they're struggling with? Usually there's always some point in that decision process, development process that they're kind of bumping up against and need some help with. And so what I'm going to do is talk about those conditions that are presented and how we chose to use MBSE to help solve and address some of those issues. And then And so I'll talk about how we apply MBSE and then the success that came away. So with regard to full motion video, there was a new capability being proposed within the organization for dealing with full motion video. It was a new approach for doing full motion video. It was competing with a legacy approach for dealing with video, and they were getting prepared for a demonstration of this capability to a set of stakeholders. And what they found out is that it was difficult to set up an apples-to-apples demonstration with legacy software. Convincingly, you could say, oh, on one hand we can solve video this way, and on the other hand we can solve it this other way. But in the end, the stakeholders were just seeing video, and it was hard to see what was really going on underneath the hood. And so the stakeholders were coming around with a misunderstanding of the benefits of the new software, and it was really not. It was hard to progress any interest in this new software. So we came in with an MBSE approach. Very basic system engineering stuff, very elementary compared to what the real power of MBSE. But what we decided to do was develop an executable behavior model of the operational activities involved in using full motion video. We first did that with the legacy software suite, and then built another one, a second one, for the new full motion video software. And we were able then to compare operational behavior. And so we were able to address MBSE for a particular problem, and maybe it wasn't a complete implementation of system engineering. I mean, we weren't dealing with requirements per se. But nevertheless, we had some success when we were able to show our study, our work. Stakeholders came away with a better understanding of the new software and the benefits that it had and the shortcomings of the legacy full motion video. So how did we do that? What we did is we worked with our stakeholders, and through a series of whiteboard sessions, we became aware and we came away with an understanding of the legacy software. And what we have here is this operational functional flow, and I just have them lined up here in a set of steps, 10 or 12 of them, and you can see that there's some logic here, step 1, step 2, and then you can go either or in step 3 or 4, and it goes on. There's a lot of different information here being exchanged, and if I kind of zoom in here on the very first part of it, you can see video coming in, you see a command coming in, and then after that command, the video frames are sent, and some other data is being coordinated. You get some coordinates, and then after step 4, the users start to use a second set of software. So it's a software suite being used, and so these coordinates, whether they're general coordinates or estimated coordinates, are being used in step 5 to align images, find a reference, and eventually what they do is they eventually find enough information here that they can get down to a detail enough so that they can do some targeting. And so we're slowly getting closer and closer to a refined accuracy. And we can also now simulate all these steps in that functional flow that I showed earlier, and we can show that steps 5 and here step 7 are taking a really long time, tend to be very human intensive, and we can kind of show that a lot of that information, that's where a lot of the time is taken with the legacy software, and this wasn't readily available or visible in the demonstrations because in many cases they used canned examples, and so that step 5 and step 7 magically went very fast. But when we kind of showed it in this framework, we could justify the fact that sometimes on the first try it doesn't take, it takes a while, and it's always going to be different depending on what you need to look at. So we're able to kind of describe that. And then when it came down to the new software, we were able to build out another functional flow. And amazingly, it only took 3 steps. And amazingly, it only took one software suite, the new software suite. And you can see video coming in here, a command coming in, and then the frames immediately being processed and coordinates being delivered. And what we could show is that the timing here was very quick. That we did not have any humans in the loop. The processing really was being done ahead of time based on metadata embedded in the video stream, and based on that, you could take advantage of that information, that technology, to get you better accuracy quicker. And as you can see, we went from like 600 time units down to 21. So, you know, effectively you're taking the human out and you're not juggling so many different sets of data and different software, pieces of software. And so everyone came away with a good understanding of what full motion video was. The stakeholder community began to buy into that, and after a few more hurdles, I think it's starting to get implemented now. So the second application here for MBSE was with a system for collecting tactical SIGINT. The initial conditions here was that the PMMI organization wanted to get started with developing their system. They had some budget and they wanted to get started, but the way things worked within the Marine Corps, they really couldn't get started until they were given a set of operational requirements, and those operational requirements came from outside of the system command in Quantico. You know, going back to those hierarchy, it was coming more from headquarters, and well, headquarters groups that are, you know, resident at Quantico, but nevertheless, they were waiting on these operational requirements. So what we did is we started to work. We started to use MBSE to help describe TSCS in terms of its legacy systems, the TPCS and REP, and we were able to engage with representatives of the operational community, operational forces, to help develop some operational requirements. And we, as engineers, we went ahead with our analysis of, you know, operational activities and operational requirements, but then we were able to use that body of information to engage with stakeholders and work things out together to come to a common vision of what the system design needed to be. And I felt this was a very successful implementation of MBSE, because in the past, operational and engineering groups kind of were at loggerheads, and the operational folks were accustomed to being very detailed in their operational requirements, almost to the point of specifying a system design. And the engineers kind of, you know, of course, didn't like that. They wanted to have their own latitude, really, to implement it in the best way that they felt possible, and they didn't want to be constrained by some misunderstanding, perhaps, of maybe what technology could do. So with our MBSE artifacts, we were able to kind of lock down preliminary designs. We were able to lock down some operational requirements and understanding of operational activities, and because we were able to lock that down, we had a body of information. Now we were kind of able to take the people out of the equation and just use the artifacts, and people began to get that trust and work together more as a team. So we were really able to see that the way MBSE can help improve teams. I do mention here that we were able to also generate architecture elements from this work as well. All right, so again, we did another whiteboard session, just like we did for full motion video, and in this particular situation, a lot of things are going on in parallel. You're doing collection, processing, reporting, and exploitation all at the same time, and you can see there's a number of different steps that are going on here and different inputs and outputs. I think I drill into one of these, not with a lot of detail here, but you can see that, you know, you're getting some threat information here by the radio battalion, and they're setting up their plan for collection, how they're going to go about things, and then they kind of go out and start acquiring the information, the signals, and processing them. And it was this, you know, agreed-to model that we vetted within our community of engineers and operational stakeholders, and it became kind of a basis for a lot of work. And not only did that group appreciate it, but a lot of other groups that saw it later that were maybe more involved in testing or writing of system requirements, they all found this to be very useful as a good starting point to start our conversations. And this also helped us kind of, you know, converge on a set of project terminology in a way. You know, we always talk about lexicons and how important it is to get on the same page, but we were able to start that process based on the functional behavior of our system. So the lexicon was really rooted in the behavior that we wanted from our system. Another aspect of this, we were able also to look at the system design and show, you know, how the system X interacted with its externals. And it's going to not belabor you with a lot of acronyms, but we were all able to kind of understand this association. Where does the system exist? Where does the human exist? What other humans are out there in our context that operators may need to communicate with? What other systems in the battle space does our system communicate with? And how does it you know, receive instructions and report output, right? We all wanted to kind of understand this, and we found that as we were talking with stakeholders, it was really hard to lock down, you know, just generic end-to-end interfaces from, you know, the specific step-by-step linkages, if you will, of how an interface is implemented. So it was really useful for us to kind of help draw these pictures out so that we could tell each of those stories. And so we were able to get down to some really nice detail in showing how, say, some of these different hardware boxes are actually embedded in a hard case with slots. We really down to some nice detail to show exactly what might be changing in future implementations of our system. We were really leveraging a lot of the legacy stuff, and so a lot of that shows up here in our diagrams. But in some cases, we're changing software. In other cases, we might be combining hardware. And then once we had our system design, we had our system functions, we were now able to kind of generate system viewpoint information. And we were able to use the SV1 and SV2 from our design information. We had system functional view. I didn't show you that system functional flow, but we did generate one. I did show you the operational flow, which is like the OV3, and of course I showed you the context of the system, the SV1, but we also had another operational view that helped with that aspect. So now you're seeing how the architecture was really seen now as a byproduct of this information. So the methodology we were using here was really system engineering, just basic system engineering. But now you can see that the benefit here is we get our architecture implemented for us along the way. Okay, now the last case study here is an application for the entire portfolio of systems. So, you know, we mentioned PMMI is doing intelligence, surveillance, reconnaissance. It's doing SIGINT, GeoInt. So there's about 20 different systems, and they manage them at different tiers. So tier 0 is the highest level management at the PMI level. When you're talking about specific programs or projects, that's considered tier 2. And so what I've explained prior has all kind of been at the tier 2 level. Now what we're looking at is that we're kind of look at the big picture and look at how all these systems come together. It's essentially systems of systems, right? And so we wanted to take a look at these systems in their physical design and interactions, their functional design and interactions, and try to understand what capabilities they're offering, what requirements they meet, and what standards they adhere to. And in many cases, we were doing some re-engineering here and trying to understand these things based on what we have in the field. So at this time, what was going on in the project was that there was an interface control working group stood up to help understand many of these aspects. And so we developed a context model for the portfolio based on artifacts that were collected previously in architecture and in requirements and through interviews with subject matter experts and through the learning of this new working group that was stood up. And so we were able to kind of use MBSE to help tell that story, but also we went a step further and took a look at it from a design and functionality point of view to kind of see, you know, how do all these systems, these 20+ systems work together as a unit, as a system of systems to deliver capabilities. So the success here was that we were really able to address some questions that were being levied on our sponsor about the strategic planning of PMMI and what changes, what impact certain changes might have on their portfolio. They wanted to understand where the redundancies might lie, and our artifacts help them tell that story. And another nice thing what we were able to do is we were able to aggregate a lot of the different sources of information that existed previously, like the myriad of architectural products and viewpoints, different requirements documents, etc. We were able now to put those all into a single integrated model, and now the sponsor, our sponsor client, was able to better understand how MBSE could help aggregate and track all this information. So this is kind of an example of what the team put together, you know, in a for MBSE kind of way. They went through all the 20 different systems and maybe even got some of their subsystems mixed in, and some of them were system oriented and some of them were operationally oriented, and so they came away with a node structure here showing all the communication patterns between different systems in the in the PMI portfolio, either, you know, from a systems point of view or from a operational point of view. It's all here, and you can see it's all color coded very nicely. There's a nice legend, and you can you can understand the meaning of all these terms. I think the gray boxes are external, the green are operational. There's a code. So at any rate, what we were able to do with MBSE, we took all this information, same information that you're seeing here on the screen, but we are now able to aggregate it and associate it at higher levels of abstraction. And so what we came away with was essentially that PMMI, our portfolio, is really interacting with really 6 elements. You know, you've got a threat that's out there, you've got the warfighter. You know, we know that those two are out there, and then you've got a collection of systems from the intelligence community, so a collection of systems that are managed by joint forces. You've got some others that are out there that are, help operate with coalition forces, and then you have some other systems that are U.S. Marine Corps systems but interact with PMMI, and that's it. You know, basically what we're doing is grouping things in a very high-level, abstract way. But this was a very powerful way of presenting the problem. But of course, this isn't going to get you the answers that you might need when it comes down to how to interoperate and integrate. So, but based on that same information that's in the repository, it was very easy for us to generate the next level of detail. And here what you're seeing is a system, a view of the portfolio at a lower level of granularity. You're now beginning to see in these white boxes the names of all the systems in our PMMI portfolio. Looks like I can maybe zoom into this slide. Let's see what happens. Yeah, so you can see here with the D6 Marine Corps here on the left is interacting with something we call the IAS family of systems. It interacts with something here on the bottom called TRSS TRIS, and I don't want to go into all the details here and explain the acronyms. It's alphabet soup, but we're beginning to see how some of these interfaces line up, and really kind of where some redundancies are. You can see. You can see, you know, there's D6 has some interfaces here with IAS. It has some interfaces with PEG. You can see externally our joint systems are talking with both D6 and TCAC and IAS. You know, which ones does it? So there's not one single point of contact here. You know, there's some issues here that the Marine Corps may want to deal with. So this was a nice view of the system that came from our MBSE repository. It didn't require, you know, another effort of modeling. It was basically the same information that drove the previous diagram. And again, here's another view of it. zoomed in here where you're seeing other aspects of the communication. And this was was much of a revelation to many of our stakeholders, just to kind of see at this level. Another thing that we were able to do, again, all driven by the information that was already there, we just organized it and rolled it up. We were able to zoom in on a particular system that was in those previous diagrams, and one called MSIDS here, and you can see here that it has 3 external systems that it operates with, and they're all Marine Corps systems. It's the IAS, an aircraft of some type, and the TEG system. And this was another really powerful way for us to kind of look at the context of each of these individual systems, and I think we can also go in to the details of that system, because they had that information at their, and this is kind of at the level where they collected the information. So this is really how we input the information into our system. They knew about the base station, they knew about the outstation, they knew about the video camera suite, they knew about the workstation, and they knew how they kind of interoperated, and through that effort, we were able to collect this information and then roll up everything else that you've already seen. So this is where this is really the starting point. But if you notice, this particular diagram has 2 externals. I showed you 3 on the earlier one. That's because they had more than one view of their system, and it came from different artifacts. So because they had multiple different artifacts, we were able, through our MBSE, to synthesize that information and aggregate it. And so they were able to see just the one aggregate picture. Another thing we're able to do with this effort to really kind of show the ability with MBSE is to show a capability analysis. So we took all these systems that were in the model. We came up with operational functions that they performed, and then tied them to capabilities that were required of them. So we took some capabilities that were came from some official Marine Corps lists of things that the Marine Corps of PMMI needed to do, and then we basically are showing a traceability of how they do that. So for example, on 214 at the bottom, we can assess the intelligence operations, and we can do that by conducting intelligence production operations and deliver that through some different systems here. And then I'm also showing you some gaps on this slide, and it was very interesting when we presented this to our sponsor. It gave them some thought to say, like, well, really, how do we monitor and collect? How do we do the tasking? Is that something we do? Is something else? Why did that not show up in our analyses? So it gave them some thought to maybe where they might want to put resources in the future. So this gets to the summary slide now. What we've shown you here is that MBSE provides a model now that unifies system engineering and even architecture, and it provides a natural language syntax so that we were able to talk about functions and how those functions are allocated to systems, and requirements, and what functions form the basis of those requirements. Ways to really talk about system engineering. And of course, there was a lot of visualization here where we showed different ways of diagramming a situation and using modeling and simulation to understand that system. And from the value takeaway was communication. We were able to engage with stakeholders. We developed better SE products, which helped us develop better architecture artifacts, and it helped us improve cost, schedule, and performance. So that brings me to the end. Are there any other remaining questions out there?
Thank you, Mark. Yes, we do have a few questions. Robert asked, you've told us what you can do, and I think we know that, but most companies are asking for hard ROI to justify the cost. Did MITRE do any computations that can be shared?
No, we didn't. I think we used some that came from some INCOSE studies. There are some out there on the net. I could see if I could provide those. Again, it is hard to do ROI to really justify beam counting. What the closest we did for our sponsor is when it came to architecture efforts, we compared our model-based system engineering approach and maybe previous architecture studies. So in the past, there was like an effort that was started in a particular project in the Marine Corps, and they have, you know, a laborious 20-step process that they go through to start the architecture and get it reviewed and by all the stakeholders. So in this particular case, it took maybe 2 calendar years, you know, just talking calendar time, to get their architecture through their hoops. And what we did is we just kept track of our hours, and we showed that when we were doing, I think it was TSCS, it was the second case study, we took all the hours we spent developing those system engineering artifacts, and in the end looked at that as a total, because those system engineering artifacts helped us with our architecture. We then compared, you know, like how long did it take us to do TSCS architecture compared to this 2-year effort, and we realized it took only, you know, 3 or 4 months of effort essentially. So we were really able to cut it down, you know, by more than half. In terms of the time it took. Now, that's still not ROI in a business sense, but it's getting closer, and it's still qualitative, but we were able to begin to quantify it in that way. So as you do your MBSE, maybe you could look to try to compare it to similar tasks that your organization has conducted in the past.
Nice answer. We do have more questions. I encourage anyone who has a question to go ahead and submit it so that Mark can answer it here live. Daniel's asked, how big is your MBSE team, and are there different roles?
That's a good question. We were able to get this done with about 2 or 3 engineers. A lot of it was me, and a lot of people that I'm trying to train on MBSE and system engineering and how to engage with stakeholders. You know, tooling is part of it, but as you can see, we really had to get in and facilitate a lot of meetings. So there were a lot of different roles to play. I played more of the facilitator. We had some people on the team that specialized more on the architecture part of it and making sure we had the right expression there. And then we also had some people working on just doing like the functional role of it, the simulation part of it. But you know, with system engineering, I really think, you know, we play multiple roles. We really do. It's hard. I think it's hard for us to be effective if we're just doing one thing.
Okay, I think that answers his question. Yeah. A question from Jacob. What are the biggest barriers to communication?
Let's see. I think it's jargon, you know, in one word. It's not only just, you know, specialized words or phrasing within a discipline. It's just kind of confusing jargon. It's inconsistent phrasing and words. And what's worse is, like, if there's a word out there that 2 stakeholders have 2 different definitions of, you know, if they nod their heads and they think they understand it, when in reality their definitions are different, you may not notice that for months down the line, and you may not notice it till you're at, you know, some design review or test situation. So you really want to get at that jargon and cut into it as much as you can, and you can do that through the MBSE to kind of help define those behavior elements, those functions within your system, so that there's consistent referencing of those, and then that'll help drive your lexicon and hopefully help cut through some of that. Now, that's just the verbal aspect. There's also, you know, visual jargon too. You know, your diagrams, depending on your stakeholder, your diagrams have to be, you know, customized to your stakeholders. I mean, if you're dealing with upper management, they're going to have to be clean and concise and really readily understandable. But if you're talking with your engineering teams, you know, they're going to need detail. They're going to need some granularity. So that's what makes it hard, is that not one diagram is going to be able to do it for you. But those I find are the biggest barriers to communication, and barriers for getting teams to work together.
Okay, and we have one final question from Lauren. What is the best way to get started with MBSE?
I think it gets down to the value proposition and understanding what the needs of your organization are, what's the big pain point. If you can identify what kind of system engineering issue they're dealing with and hit that head on, then sometimes you can get away around this ROI issue. You know, you're not coming at it just from an abstract kind of way. You're coming at it from a very practical perspective, and if you can kind of show how MBSE can help with that particular situation, those initial conditions, then you can be more successful in persuading groups and organizations to adopt MBSE.
Okay, thanks, Mark. That wraps up the Q&A that we have. If there are any other questions or comments for Mark, don't hesitate to send him an email. He would be happy to hear from you.
Sure.
That's on the invitation. Thanks for coming today. We hope that you enjoyed the 3 case studies presented by Mark. We have 2 webinars coming up. Genesis for Core Users by Sarah Sumner on May 3rd, and Adapting Core and Genesis to Support Development Methodologies and Processes by Gareth Digby on May 24th. Links to register for both webinars are on our website, and I'm sending it out via chat right now. A reminder, at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in the future. That's all for today.